This is Algebra 2, Unit 5, Lesson 10. In today's lesson, we are going to focus on how to combine functions. Sketch the graph of the function defined by the sum of function f and each of these functions. So remember that the value of a function is the y value at any given input for x. So if we want to add these together, we're going to go to the values of x and we're going to add the values of y together. And we want to find points where the values are clear. So we can see that at negative 10, we have 0 plus 3 equals 3. At negative 8, we can see 0 plus 3 equals 3. At negative 6, we can see 0 plus 3 equals 3. At negative 4, you can see that we are just starting to rise above 0, and adding that to 3, we would be just slightly above 3. At negative 2, we're just a little bit higher above 0, and we're still at 3, so we can go up just a little bit more. At 0, we're at 1 and 3, so 1 plus 3 is 4. At 1, we can see that we're at 2 and 3. 2 plus 3 is 5. At positive 2, it looks like we're at 3 and 4, which is 7. And at 3, it looks like we're at 3 and 8, which would be 11. So now we're off the graph. And now we can draw the line that connects these points. So this red line would be f of x plus a of x. Now we'll look at the top right example. Again, we're adding these functions together. So we have negative 10 plus 0 equals negative 10. Negative 8 plus 0 equals negative 8. Negative 6 plus 0 equals negative 6. Negative 4 plus slightly above 0 equals slightly above negative 4. Negative 2 plus slightly above 0 would be slightly above negative 2. 0 plus 1 equals 1. 1 plus 2 equals 3. 2 plus 4 equals 6. 3 plus 8 equals 11. And now we can draw the line that connects these. And this would be f of x plus b of x. You're just going to each value of x and you're adding the values of y together. Now we look at the bottom left. At -6, we have 0 plus 9 equals 9. At -5, we have 0 plus 6 equals 6. At -4, we have 0 plus 4 equals 4. At 0, we have 0 plus 1 equals 1. At 2, we have 1 plus 4 equals 5. At 4, we would have 4, and we're off of the graph. So now, with the dots that we've drawn, we can draw the new combined function by connecting the points and this would be f of x plus c of x. We're just finding x values where both functions are at identifiable points. We're adding the y values together, and we're plotting the new y values. And the last one on this bottom right, we have 0 plus 0, 0 plus 0, 0, 0, 0, 0, 0, 0, until it finally starts to split. Then what you'll notice is these functions are opposite y values. We'll end up with +1 and -1, which equals 0. We'll end up with +2 and -2, which equals 0. We end up with +4 and -4, add together to 0. We have +8 and -8, which add together to 0. So when we have these opposite y value functions, when we add together, it's going to be 0. So our new line is just going to be the x-axis. And this would be f of x plus d of x. So when we combine functions by addition, we're finding the corresponding x points and adding their y values together to plot a new point at that x value and that combined y value. If you have any questions about how I solved this practice problem, please use Classroom Time now to ask for clarification. Here are graphs of two functions, f and g. The function h is defined by h of x equals f of x minus g of x, for which values of x is h of x equal to 0. Explain how you know. In order for me to get a value of 0 for h of x, I would need f of x and g of x to be the same, because anything minus itself is 0. So this would be the points where the graphs cross each other. So at -2 and at the origin. So the values of x would be x equals -2 and x equals 0 because the y values are the same. Number 2. For which values of x is h of x less than 0? Meaning h of x is negative. So h of x is less than 0 when, if I'm going to get a negative number, then I need a smaller number minus a larger number. So I need f of x to be smaller and g of x to be larger. So that happens between -2 and 0 when the parabola for f dips below the straight line for g. So we would say -2 less than x less than 0. And we are not going to include -2 or 0 because those are the points where it equals 0. And we only want the points where it's less than 0. The second part of number 2, for which values of x is h of x greater than 0? H of x is greater than 0 when, to get a positive number from subtraction, f would need to be larger and g would need to be smaller, because a larger number minus a smaller number gives you a positive number. So that would be anywhere the parabola for f is above the straight line for g. So that would be negative infinity less than x less than -2 and zero or greater than 0 to positive infinity. So we would say 0 less than x less than positive infinity. So if we look at this, it's 0 at the points where they cross. It's less than 0 in the middle. And it's greater than 0 on the ends. Now they want us to sketch a graph of h. So we already know at -2 it's going to be 0, and at the origin it's going to be 0. At -1, it looks like we might have 2 minus 4, which would be -2. At -3, it looks like we have 14 minus 9, which would be 5. At +1, it looks like we have 2 minus -4 or -3, so that could be 5. At 2, it looks like we're about 6 minus -6, which becomes 6 plus 6, which is 12. And out at 3, it looks like we have 14 minus -9, which would be 14 plus 9, which is 23. So we could put a point right here. And then we could draw the line that connects them. And we have this parabola, which would be h of x. So if we are combining functions by subtracting, we are finding the y value of f and subtracting the y value of g at each value of x. If you have any questions about how I solved this practice problem, please use class time now to ask for clarification. The table shows the approximate United States population and the amount of sugar consumed in the given years. Our top row is the year, the middle row is the population in millions, and the bottom row is pounds of sugar consumed in millions. Number 1. About how many pounds of sugar per year were consumed by each person in 1800, 1850, 1900, 1950, and 2000. So in 1800, we have 30 divided by 5, which equals 6. In 1850, we have 460 divided by 23, which is 20. In 1900, we have 3,000 divided by 76, which is approximately 39. In 1950, we have 12,000 divided by 161, which is approximately 75. And finally, in 2000, we have 32,000 divided by 291, that is approximately 110. And number 2 wants us to plot the numbers on the graph. So 1800 is 0 years after 1800, and we said there was 6. 1850 would be 50 years after 1800, and we said there was 20. 1900 would be 100 years later, and we said there was 39. 1950 would be 150 years, and we said it was 75. And finally, 2000 would be 200 years later, and we said it was 110. So these would be our points. If you have any questions about how I solved this practice problem, please use class time now to ask for further clarification. In the table, we have the function f, which gives Claire's height f of t above the ground in feet t seconds after starting her descent from the top of the original Ferris wheel. Today, Claire tried out 2 new Ferris wheels. The first one, whose height is given by the function p, is half the height of the original and turns at the same speed. The second one, whose height is given by the function r, is the same height as the original, but turns at twice the speed. Number 1, fill in the table for functions p and r. So what you need to realize is if we have half the height in p of t, then this is a vertical scaling. And on r of t, if we have the same height but twice the speed, and speed would relate to our time, which is our x, then this is a horizontal scaling. So, when we're filling in the vertical scaling, remember that is the y value that is being affected. And when we look at these, time is x, and f of t would be y. So when we're filling these in, if we want half the height, we multiply y by half. So half of 212 would be 106. Half of 181 would be 90.5. Half of 106 would be 53. Half of 31 would be 15.5. And half of 0 would be 0. Next, we're doing a horizontal scaling. And with a horizontal scaling, it's the x that's being affected. So remember, if I want the horizontal scaling for r of 0, then I need to match 2 times the original. So 2 times 0 is 0. So we would use the y value for 0, which is 212. If I want 5, 2 times 5 is 10. So we match the y value for 10, which is 106. If I want 2 times 10, that's 20. And the y value for 20 was 0. If I want 2 times 15, that's 30. But I don't have a 30. So we don't know. And if I wanted 2 times 20, I would need 40. We don't have 40, so we don't know. Number 2, explain why there is not enough information to determine r of 15 and r of 20. For number 2, we would need f of 30 to find r of 15 and f of 40 to find r of 20. And we don't have those. And number 3, express P and R in terms of F. So P of T equals 1/2 times F of T. And R of T equals F of 2T. Because P of T was a vertical scaling, so we multiply F of T by 1/2. But R of T was a horizontal scaling, so we had to find F of 2 times T. If you have any questions about how I solved this practice problem, please use class time now to ask for further clarification. The graph of each of these quadratic equations is a parabola. Explain how to find the vertex of each parabola by applying transformations to the graph of y equals x squared. The graph of y equals x squared has a vertex at the origin, 0, 0. So number one, this -1 from the x in parentheses tells us to shift right 1 unit. That puts the vertex at 1, 0. Number two, we have the -1 inside parentheses again. So again, shift right 1 unit. And now we're adding 5 outside the parentheses. So this is right 1 up 5. That puts the vertex at 1, 5. And for number 3, we still have the -1 in parentheses. We're still adding 5 outside the parentheses, but now we've also put a minus sign in front of the parentheses. So this is right 1, up 5, reflect across x-axis. This flips it upside down, but it doesn't change the vertex. The vertex is still at 1, 5. If you have any questions about how I solved this practice problem, please use classroom time now to ask for further clarification. Here is a graph of a function f. Number 1, use the graph to explain why this function is neither odd nor even. So if this was an odd function, we would be able to rotate this graph 180 degrees and get the same graph back. But what we would actually get, since this goes through the origin, this point would stay the same. But this +2 would rotate around and be at -2. And we would see a parabola that looked like this. So it cannot be odd because when we rotate it 180 degrees or reflect across the y-axis and the x-axis, we do not get the same image back. Now, if this was an even function, we would be able to reflect it across the y-axis. But the point at the origin would stay the same, this positive 2 would become negative 2, and we would have a parabola that looked like this. In order for this to be an even function, when we reflect it across the y-axis, we would need to get the same image back. And you can clearly see the blue graph does not line up with the black graph. So this is how we would use the graph to show the function as neither odd nor even. Number 2. An equation defining f is f of x equals x squared minus 2x. Use the equation to verify that f is neither odd nor even. So, if this is even, f of x equals f of negative x. So we're going to substitute negative x in for x. F of negative x equals negative x squared minus 2 times negative x. Negative x squared becomes x squared, and minus 2 times minus x becomes plus 2x. This does not match f of x because it's now plus 2x instead of minus 2x. So it's not even. If this were odd, then f of negative x would equal negative f of x. But that doesn't happen either, because we still have x squared. This part is not opposite. So it's not entirely the same, so it's not even, and it's not entirely opposite, so it's not odd. If you have any questions about how I solved any of these practice problems, please use class time now to ask for further clarification. If you have time remaining in class, you may use it to work on getting more Khan Academy skills to proficient or mastered on the digital SAT math so that you can be eligible for the prizes that are based on the different skill levels completed. If you have any questions or need any help with that, please use class time now to ask for help as well.